Sorry, running a few minutes behind. My bad. Man. All right, so I kind of mentioned today. I'm gonna go over just how to clean up these reads, right? Because these reads, right, this specific library is pretty good, right? This Testis library that I'm working with is a pretty nice library, but that doesn't mean all libraries are nice, and a lot of them are pretty junky, and there's bad reads in there that we should get rid of. Furthermore, there can be adapters in there that can throw off mapping or assembly downstream analyses. So we want to get rid of those as well. And so I've already done some of this just to save some time. But nonetheless, we'll look at this process. And so everybody in this class, I sent you a line that's going to be a Trim-O-Matic line. And so I also have there should be a link in the description to Trim-O-Matic. And so this is my go-to cleaner. It's a pretty popular cleaner because it does a lot of things simultaneously. It'll remove adapters and it can clean up bad, junky reads. So we're going to look at what that does and how it works and how to run this program, because it's not exactly, it's an easy command, but it's just long. It's long, and because it's long, it's easy to put in a typo and throw an error. And as much as I like Trim-O-Matic, it's not very good at troubleshooting errors that pop up in the command line. You know, whatever. Not everything's perfect, but we get as close as we can. So Trim-O-Matic, so on this machine, you should see I have Trim-O-Matic in this opt directory in Trim-O-Matic 038. So this is a little bit older version. I think that current version is on 0.40. So this is, it's going to be like 99% the same. It's just a couple of bugs get fixed. Might run a little faster, things like that. But ultimately, I mean, it's effectively going to be the same thing. The parameters are certainly going to be the same thing. And so if we look in this directory, there's not much here. It's just a Java program. So Trim-O-Matic is constructed in Java. But it does give us this adapters directory. So just taking a tour of the adapters. As I mentioned, like adapters are required for the Illumina prep, right? So we have our RNA or we have our DNA and then ligate Illumina specific adapters to the ends of these fragments, right? But there's more than one adapter, right? There's dozens of adapters. And so Trim-O-Matic already comes with several known adapter sequences from Nextera. A lot of these are just from companies or prep kits. So like Nextera is a specific prep kit. TrueSeq is an RNA prep kit. Same thing, right? Single end, paired end, etc., etc., etc. Right? And so they're already there. They come ready with Trim-O-Matic, but I don't want to run. The adapters aren't always known, right? FastQC can kind of help identify our adapters, but even then, it may detect an adapter that's not actually known by FastQC. It'll detect a repeated sequence at the 3' end, but it won't necessarily identify the adapter. Whatever. So whenever we run Trim-O-Matic and we're looking for adapters, right, adapters on the 3' end, it's going to scan through whatever file that you supply, right, Nextera, TrueSeq, whatever. But I don't want to run this program 4 different times to check for 4 different adapters. So what I've done is basically combine all of these output files or all of these adapter files, like star.fa into all adapters, right? So all adapters is made by me, right? It's not going to come with Trim-O-Matic. It's made by me by doing this kind of command. But nonetheless, some hiccups will happen In this, like, there's a new line character, so if you're doing this yourself, you should look at this file and make sure that it's going to stay in the proper FASTA format. Because whenever I run this command, oh, I can't do that here. Let me just run that to my home real quick, just so we can see it. Right, so there's going to be some problems here. Like, here's a stupid problem. Right, the end of one adapter. This is basically the start of a new file. So right, that's the end of the first file, and that's the start of the second file. And so there's a problem with a new line character. It's going to put the prefix, or it's going to put this next fastest sequence on the same line. So that would have to be edited to get rid of. Right, I've already done that for hours, so we don't have to worry about it. But it happens a couple of times. Right, happens there. Happens there, right? So those just need to be quickly fixed before, if you decide to do it this kind of fashion, that needs to be fixed before running Trim-O-Matic. But I am going to use something like this file, remove all adapters, go back to where I was, right? So I've already fixed this, right? That problem doesn't exist in this adapters file, right? I've already fixed that. All right, and so I'm just going to provide a generic line. This is good for the data that we're working with, but every library we should adjust the cleaning parameters as needed, right? But this line is going to work pretty well most of the time. Since it's a Java program, we kind of have to call it in a weird, kind of wonky way, honestly. It's pretty true of adapter sequences of Java programs in general. Not all Java, but at least this one. So I'm going to go to my FastQ. Now we're gonna see some files in here from me running Trim-O-Matic already. Right. So I already have done this. Right. I've already run Trim-O-Matic on these reads. And so we see the cleaned reads and we see the unpaired reads. But I'll talk about how all this stuff is generated from our Trim-O-Matic line. So how this line goes, as I said, it's kind of long, but it's going to be java-jar. This is just requirements. I can't explain why. It's just this is what I have to do. And call the program from Trim-O-Matic. It's just under case Trim-O-Matic. I don't know if this is by default or if this is something that I changed the name of. I'm not entirely sure what I did here. And so I'm also kind of, as I said, I put in a link to the description of this a help tutorial, at least a bit of a help tutorial. I don't think Trim-O-Matic, it works great, but again, the error output isn't exactly helpful, and I think reading the manual gets a little tricky. I don't think everything is explained as well as it could be, but then again, it's still a very awesome program. And so we can run Trim-O-Matic two different ways. We can run it as a paired in or as a single end. It just depends on what we want, right? So that's going to be described in the manual. But the first option that we have to provide is PE for paired in, because our data is paired in, right? So it's just telling Trim-O-Matic that to expect paired in data and run it appropriately. Next thing we have to do is provide our certain options. As I said, so Trim-O-Matic, if I just run this command, we should get something that resembles a help menu. Again, it's not the best help menu, but you know, it works. And so we are more or less following these rules, the parameters of the PE version, not the SE. So I need PE. I'm going to call the number of threads. So as I said, I gave this to you. So the number of threads basically means how many processors are going to work on this data, right? We have 4 gigabytes of data to go through. The more processes we add, the faster this gets up to a point. So we can decide how that works with threads. And this is up to us, what we want to provide, how many processors we want to run this as a job. For y'all, I gave you all 6. So we have about 50 processors to work with. And so if 7 of us are running 6 processors at a time, we're already up to 42. So I'm just leaving it at 6, so we can't bog this system down. We can't go over the processor amount. So just leave it at 6. It'll take a little longer, but just leave it at 6 to call 6 processors. And then we have to provide a FRED33 or a FRED64 scale. And what this is are the quality scores, right? So the quality scores of each base are either encoded as a FRED33 or FRED64. And the older stuff is FRED64, the modern stuff is FRED33. So in most cases, FRED33 is the option that we want to provide here. And so this line is going to get very, very long, right? If you saw my email, you know this thing is going to get long. So I don't want to write this all out onto one line. I'm gonna skip some lines, or I'm gonna move this onto the next line by using this backslash character. It basically reads like, ignore the return, right? Tell the computer to ignore the return. So it won't run the command. It's just I can continue this line or this line onto the next line just so it's easier to see. But once we have the threads called, the FRED33 called, then we provide our input files. So the input files are going to be our raw FASTQ files that we have accessible to us. So it's going to be the first one and the second one. Okay, right? And so that's kind of inputted here. So we're not worried about quiet or validate pairs or base in. That stuff's not really all that necessary. They're options, but we don't need them. What we need are the threads, the FRED, and the input files. So we're at this point of here in the line. Input file 1, input file 2, right? So these are our paired in raw reads. And then we provide the output files. So we're going to provide 4 different output files. We don't care about base out. Don't care about that. We're going to have output file 1 paired, output file 1 unpaired. And so I write this out as to give myself a difference. This is just my formality. Doesn't mean it should always be used, but this is just my formality. But I'll do clean 1. As I said, I've already run this, so the file names already exist. You should not be able to tab whenever you run this raw. So I always do like clean 1 and unpaired 1. So this means that if my reads survive the cleaning and the trimming, and the pair also survives the cleaning, put that read into clean 1. Okay, but if that read survives cleaning, but the pair does not survive cleaning, then put that unpaired read into this unpaired file. So we have a clean 1 for the paired good reads that will survive, and then the unpaired reads that did not survive, or the mate did not survive, or the mate did not exist. So we have that set. And then we provide the clean and unpaired for the second set. So clean 2 for the mates that survive, and then for mates that don't survive in the second file, unpaired 2. Right? Again, this is just my formality using clean and unpaired. Because I'm not even going to save the unpaired stuff. If it's unpaired, in my opinion, it doesn't survive. So I will ultimately delete the unpaired files and just keep the paired, cleaned reads when this is all said and done. Right, so that's all of this stuff. Input 1, input 2, and then the 4 output files up to this point. All right, so that's bringing in our input files, and then we have to tell Trim-O-Matic what to do with these reads. You know, how do we clean them? And so now we actually call in the parameters for cleaning, right? The specific modules for cleaning these reads up. And so the first one is Illumina clip. And so this is why it gets a little annoying. This help menu doesn't get super helpful. because it stops at that point, right? This is the bare stuff that you need, but we have to provide additional modules. And so the first one is going to be Illumina clip. Illumina clip. And so Illumina clip is going to read that adapter file and basically try to align each adapter to the 3' end of our sequence and look for a match, right? It's basically going to use the references of our adapters to look for adapters in our sequencing reads that we don't want. And so this is where it gets a little hairy, because between any of these colons, we don't want any white space. If there's white space, we're going to get a complaint, and we have to start this whole line all over again. So no white space between these colons. And again, these colons are just like, they're Trim-O-Matic specific parameters. And so with Illumina clip, we first call in the adapter file. And so that's going to be an opt Trim-O-Matic adapters, all adapters, right? So it's going to stay there. And then we have these additional parameters 2, 30, 10. I'm just going to say this is magic. This is required. This is suggested by, these are the parameters suggested by Trim-O-Matic. Don't exactly know what they're doing. Not going to lie, don't exactly know what they're doing. But this is encouraged, and if we don't have them, this program won't work. But it is something like how similar. It's basically saying like how similar to the end of the sequences is to the adapter, to the point that we say, okay, this is an adapter, cut it off. That's what it's doing. But the specifics I'm not exactly sure of how we should adjust them. Quite honestly, just don't touch it. Leave it alone, 23010, and be done with it. Sorry, I'm just kind of looking at the manual, making sure I'm not doing something stupid. Because again, if you don't have this typed in right, if you don't have every single letter correctly, it's going to throw a hissy fit and not do what we need it to do. But anyways, this line is going to get rid of any adapters that exist at the 3' end. And then we're actually going to clean our reads. And so to clean the reads, I use sliding window. Sliding window. And so this, what I provided is 530. I'm pretty confident that's what I provided. Let me double check, but I'm pretty sure that's what I provided. Yeah, 530. And so what this means, what I can't explain what's happening here. Okay, so this sliding window is going to look at increments of 5 bases from the 3' end. So we're starting at the 3' end, looking at the first 5 bases from that point, and calculating the average quality score over those 5 bases. And so this 30 is, I'm saying, if that is met, so if the average of these 5 bases has a Fred over 30, leave it alone. Don't touch anything else. Like, leave that read alone. Because again, like these Illumina reads, if they're going to be crappy, they're going to be crappy on the 3' end, probably not in the middle. So we're only trimming from the 3' end forward. And once that parameter is met, once we have this parameter set where 5 bases are better than 30, have a Fred of 30 on average, cut it off. If that parameter is not met, cut those 5 bases off, and then look at the next 5 until this parameter is met. 5 bases are over, have an average of a Fred score, quality score over 30. Okay, so that's going to take care of the crappiness of the 3' end. And then I use head clip. I think I use head crop, sorry. Head crop 5. And so what head crop is that it automatically is going to cut off the first bases supplied or the first 5 bases of every read from the 5' end. So no matter if the read is clean, no matter if it's dirty, just get rid of those first 5 bases, because there can be a little bit of wonkiness in those first 5 bases. So get rid of them. Don't even try. And then, is that my last character? No, I set a min lane. So I set this final parameter of 75, and so this is going to be adjustable. Right, all of this stuff is adjustable, and it depends on your data. Right, if you have really crappy reads and you need some of it to survive, you might change your sliding window parameters to like 520, right, just so something survives that you can work with. Head crop, so I've seen head crop of 1, head crop of 2, you know, it's whatever. Min lin is like, only keep a read if this trimming, by getting rid of the adapter and cutting off the 3' end, if we do both of that and the read is still longer than 75 bases, keep it. If we trim it, get rid of the adapter, get rid of crappy reads, and it's 74 bases or less, we're going to throw it away, right? It's not surviving, so we're just going to get rid of it. So it's basically, we're going to throw away at most 25% of our sequence until we say, this is a bad read, just get rid of it. Again, some people won't do that, but this is one parameter that I like. If my reads are kind of crappy, cutting a lot off of the 3' end, I may set this to like 50% of the total sequence, so like 50 bases. But currently, I have it set at about 75% of the raw sequence. And so at that point, I would just hit enter. So recognize on this last line, I'm not putting a dash or backslash. That's going to be empty. At this point, I would just hit enter and hope that it's going to run. But as I've said, I don't want to do this, because if I do this, I'm going to overwrite some files that I really don't want to overwrite. So I'm not going to run it. But I have already run this. So we're going to at least look at how this program looks when it runs correctly. So I should have a tmups already. Yeah. And so my nose is itchy. I can't stop. So we've talked about tmups before, and to reattach to this tmups window that had run my trim-o-matic line is tmups attach -t0. Or at least if there's a better way or shorter way, I don't know about it. But again, it's just the 0 is the name of that window or the name of that shell. Okay. I have 2 windows open here, so I'm going to go back to the original window. And so this is the original window where my trim-o-matic was run. Yeah. Right, and so we can see I have 2 examples. One where trim-o-matic did not do what it was supposed to do. I got this first a Java error. It just says Java file not found, and it's complaining about my all adapters not fast. Honestly, I have no idea why. Don't know why. But it's saying it threw an error that it doesn't exist. So it didn't actually run. And it got all of these Java IOs that said that this did not run properly. At least it didn't find the all adapters fast file. Again, I have no idea why I did not find that file, because I ran it again, I swear, in the exact same way, and I didn't get a hissy fit. So I can't explain this error, because this line worked just fine. And I can't tell the difference between this line and that line. Normally I can. If I see an error, I know an error exists. I can usually find it and fix it, but I don't know what the problem was here. Anyways, so that all ran nice and fine. and we'll see the output file. So this is what it will look like when everything runs correctly. Right, you'll see all of the adapters be input saying we're looking for this sequence for our adapters, and then when everything runs nicely, we'll have the output. And it's basically going to say how many pairs were read in and how many were both survived. So that means that in both reads, they stayed above 75 bases. They're clean for that long. So they at least survived trimming. Both reads survived adapter cleaning and crappy base cleaning. So it was only half. That's fine. There's already crap tons of data in this. I don't mind getting rid of half. But also tells us how many were forward only surviving. That just means like the first read. Like these are how many reads are going to fall into like unpaired 1. The reverse surviving, how many reads are going to fall into unpaired 2. And then how many actually were dropped, where nothing survived, right? Like they fell below 75 bases after cleaning and adapter removal, right? So if you see all of this stuff pop up, your Trim-O-Matic went well. If you see a bunch of Java I/O stuff, your Trim-O-Matic line did not run, and it's time to try to figure out what you went wrong, where, which takes some troubleshooting because Trim-O-Matic won't tell you what went wrong. It's just going to say, hey, there's something wrong here. Figure it out. Yes. And so as I said, I've already run this before, so I have, I don't want that. So I have my output files, right? My raw starting files, and then my clean files that I'm going to keep, right? And recognize it is only half, right? We started with 2 gigabytes a piece for each file, and now we're down to 1 gigabyte a piece for each file, right? So only about half survived, and that's fine. And so if we actually look at these files, if we compare like the raw to the clean, let's just skim through that, right? Everything's 100 bases long all the way through, right? But if we do the same thing, if we just look at the clean file, just for a few lines of it, oh, that's, oh boy. Yeah, so some of this stuff did get trimmed out a little bit, right? So here's like a read that it's a little bit short, like 1 or 2 bases were trimmed off. There, ooh, I thought I saw one. Yeah, so there's a good example. Oh, man, here's an example of a read that did get trimmed a little bit, right? So it probably lost 5 or 6 bases because these last few bases were probably crappy or adapter derived. So we cut all that off, and recognize we're already cutting off the first 5 bases of every read. So we're already starting with 95 bases, and if we survive 20 bases, we're going to keep it. Right, so you should. So the thing is, like in the raw file, all sequences are the same length. In the clean file, the sequence varies a little bit. So there's a good one. There's one that got trimmed down a little bit. Okay, and so we can compare our reads, the cleanliness of our reads from the original to the clean. And so we just run fast QC on this. So we would just do another fast QC run on clean 1 or clean 2. I tried to run both at once, like clean 1 then clean 2, and it threw a hissy fit. Like I can't run both at once. I have to do clean 1 first, let that finish, and then run this again on clean 2. Don't know why, but that's what's happening. But I have to do that. So I've gone ahead and saved that output in this general fast QC file, just so I don't overwrite anything. So I'm going to bring those files back over. Give me like 2 seconds to bring those files over my desktop, and we can look at those fast QC outputs to just see how our clean reads compare to the raw reads. So just give me a couple minutes. because this I haven't moved. I haven't moved these FastQ HTMLs over. That I have not done. No. Okay. So we'll look at the raw again, and we'll look at the clean. Now it's like I gotta figure out where I actually put it. Where did I throw these to? Like share. Okay. All right. So we've seen this before already. This is the raw. This is the raw output of the first file. So ERR_1. That's our threads of this first file, right? And again, I've already mentioned this. It gets a little crappy towards the 3' end. It's just something that Illumina technology does. We can also compare all this stuff here. So we have 32 million reads, 101 bases on average, and GC is 48%. So if we look at the clean, so this is the clean output file of our threads of our trim-o-matic clean reads. And so again, it's reduced by half, and now the sequence length varies between 95 and 75 bases, right? Again, we just got rid of those first 5 bases, so nothing's going to be longer than 96 bases, and the minimum is going to be 75, just because that's what we made trim-o-matic do. And also we see that our threads are much better, right? So we don't see any of this crappy lag. It's not even that crappy to begin with, but right, we just see that quality be a little bit higher. It's much more stringent. The data is much cleaner. The threads are higher. Nothing is below a 30. And so again, it's whenever we have a lot of data to work with, clean the crap out of it, right? We can throw data away. It'll be fine. So everything looks nice. Sequence, don't care about that. Don't really care about that. Quality per read, that's all fine. It's mostly 38 now. And we do get a little bit, there's still some of that junkiness at the first bit of the read, right? We saw that before. There's junkiness at the first 10 bases. I got rid of the first 5, so now there's only junkiness at the first 5 bases. But it's not that bad. GC content is probably a little more accurate. Doesn't really matter. It's about the same anyways from the starting point. There should be no ends. There were no ends at the start of this, so there's no ends now. And sequence length, most of the sequences are 96 bases, right? So most reads survived. Most reads survived. The solid majority of them were just head clipped, and that's it. No fewer duplications. And no adapters, right? So those adapters are gone. Yeah, sequence length. Wow. Let's compare sequence length real quick. Yeah, 75. So some reads, very few reads are 75 bases. Very few times, very few reads did I have to trim off 25 bases. Most of them survived or thrown out. But the solid majority was just all that happened to them was a head clip. Right, and so you can kind of see that different here, right? They're all 101, and now they're variable between 75 and 96. Duplication, did that help? It's about the same. And so there's the adapter content. So here's our original adapter content. Again, we just have like 10% of our reads have some adapter identified in it. But now we have 0% of our reads have adapter in it. So we cleaned our adapters out. And that's that, right? So I did that for both, right? You should expect the exact same thing for the ERR_2 file and the clean2 file too. Should be the exact same phenomenon. Honestly, you should do a fast QC on every library you download and clean. You should, but just because you should doesn't mean I do. At this point, I know Trim-O-Matic works. If I see it's been trimmed, I know the program worked effectively. I may check for the adapter to make sure that my adapter was indeed clipped, recognized and clipped, and figure out why if it didn't. But honestly, that's about all I do, right? At this point, I work with so much public FASTQ data, RNA-seq data. I just clean it and go, right? Most of the time, I don't need to look at it. I know it's cleaner. I know it's better, so I just move forward in the project. But at least this helps us look. Using the FastQC helps us look at how our reads were cleaned and if it was substantially better, and we can assess the quality of our overall library before we start doing anything to begin with, right? So FastQC is pretty helpful to look at our reads, make sure everything goes right. And so on Monday, we'll switch gears to downstream analyses. So this is from human testis. We know what all the human genes are, but I'm gonna pretend like we don't have a reference. I'm gonna pretend like we don't have a human reference. Then what? We have this RNA data, but we don't have the genes identified and annotated. Then what? What's next? And so we'll discuss what's next on Monday. How to process this data, how to get it from individual reads to full mature mRNA transcripts that we can analyze further. So that will be reserved on Monday, and I'll see you all again then. Practice with the Trim-O-Matic. I know it's a pain. I know it's a huge pain, but practice with it. Make sure it works, and let me know if you have any problems doing so. Until Monday, I'll see you all later.